Yeah, warm good evening to all. I'm Karthik, Assistant Professor, Mechanical Engineering Department, SNS College of Technology. Here we are going to have a small discussion about a case study on the failure of a helical gear. The in so first we are going to see this. These are the contents we are going to discuss. First is introduction. Second one is case study. Third one is experimental procedure. Fourth one is result and discussion, and fifth one is conclusion. So the first part is that this failure analysis in this gearbox, which is we are going to study, is used in the bus gearbox, and here the history in the gear has been used in the bus gearbox for 3 years. So the material used for this gear is AISI 8620 steel, and the evaluation methods we are used is visual inspection, photo documentations, chemical analysis, micro harness measurements, and metallographical examinations. So before going to the case study, we have to see what are the common types of gear failures that will happen. First one is fatigue may happen. Second one is impact. Third one is fracture. Fourth one is wear. Fifth one is stress rupture. Fifth one is the last one is surface contact fatigue. There are two types, which is pitting and spanning. So these 6 types are the failure types for the gear. So here the main cause is that it's poor design of gear sets, misalignment of gears, overloads, subsurface defects in the internal areas, and the last one is usage of incorrect material and heat treatment. So first in this case study is that the bus with the problem is that it's transmission gearbox. So here the gearbox is running hard because of its excessive vibration. So here they have found that the problem was at the 4th speed drive gear. Okay, so this is the general application of a failed gear. In a naked or in a visual inspection, we can see there are some main breakages which is seen here. So these are the breakage paths of that gear. See, in this side the teeth are is in good alignment as like here, but you can see there are some breakages. So this is one of the so this is the general appearance of the failed gearbox. The next parameter is that this is the common parameter. So it's a 36 gear helical gear. The helical angle is 15 degree. The module is 4, pitch circle is 150 mm, outer diameter is 150, face width is 42 mm. So this is a common helical gear. So first comes the spectrum analysis, the micro harness measurement. The first it reveals that it is an AISI 8620 carbonized steel with a core harness of 413 HP and surface harness of 550 HP. You can see there is some difference in the core and surface harness. Maybe this gear can be undergone surface treatments. So case depth is 0.63 millimeter. So this microstructure contains of martensite and retained arsenate. So this is the microstructure of an this failed gearbox, where this black colors are martensite and this white colors are nothing but the retained arsenates. So as in the visual application, as I already said, this adjacent teeth are the break due to the fatigue. There are some triangle pieces has broken out, and the crack initiation with bench marks can be seen in the naked eye. The cracks seen in the pitch line, and there is no corrosion media which is on the fracture surface. So in this photograph we can see there are some breakages. This is the starting point of the crack. So this first it is due to the pitting and spalling. Because this pitting and spalling is one of the main gear failure that occurs at the high speed gearboxes, and it can be used for commonly. This spalling is caused due to the excessive contact stresses. So this is the photograph where you can see this is the spalling area, this is the destructive pitting areas. So the spalling and pitting are the major causes. So in coming to semi-NIDAX, you can see in semi inspection it is a fatigue based crack initiation and propagation, river like patterns which indicates that it is a fatigue, and EDA supports that the fracture surface has the gear geometry, and there is no associate components are present. So this is the crack initiated area, and the crack is propagated, and the mean cracking happens. So in conclusion, we can say the composition microstructures are found satisfactory. The main failure is due to fatigue, and the fractography test is also confirms the same. As this is due to the misalignments, the failure occurs, and the formation of destructive fitting and spalling is at one end is due to the load concentration on the other area. So that's all for today. Thank you. Have a great day.